LeetCode problem 162. Find peak element. May sound simple, but it mirrors real-world challenges. Spotting spikes in CPU usage, peaks in financial trends, or anomalies in a data stream. It's a classic in disguise. And while brute force gets you started, it won't fly in high-stakes scenarios or interviews. To rise above, we need something leaner, faster. Let's dive in and hunt that peak with precision. Let's kick things off with the most basic move, brute force. We'll check each element one by one to see if it stands taller than its neighbors. Here's how that looks in code. First up, let's store the length of our array. We'll need it to control the range of our search. Then we loop through each index, treating every element as a possible peak until proven otherwise. At each step, we compare the current number to its neighbors. But edges are tricky, so we simulate negative infinity using the minimum integer when we're at either end. With those edge cases handled, we check, is this element greater than both neighbors? If yes, that's our peak. Return the index right away. The problem guarantees at least one peak, so this next line should never run. But we include it for completeness, just in case. This method runs in big O of n, scanning up to 100,000 elements one at a time. Space? Constant. No extra memory needed. Just watch your bounds near the edges. And no overflow worries, we're not doing any math beyond comparisons. But scanning every element? That's still too slow at scale. Let's bring in the heavy hitter, binary search, to shrink our search space fast. We begin by setting our search window, left at 0, right at the end of the array. We'll carve it down from both sides. Now into the loop. As long as left is less than right, we've still got ground to cover. Each round, we grab the midpoint. That's where we test the terrain to decide which side hides the peak. If the middle value is greater than the next one, the slope is dropping. So the peak lies to the left, maybe even at mid. Shift the right boundary down. But if the slope climbs, we head right. The peak must be somewhere beyond mid. So we raise the left boundary. Eventually, left and right meet. That means we've zeroed in on a peak. We return the index where they've converged. This version runs in big O of login, just 17 steps for 100,000 elements, lightning fast, and still constant space, ideal for interviews and production code where speed counts. So we started with a full scan, waddling through every number, simple but slow. Then we brought in binary search, trimming the search space with every step. It's not just faster, it's elegant. And when real-world systems demand real-time answers, that's what sets you apart. Whether in an interview or building scalable systems, knowing how to turn a linear grind into a logarithmic leap is your secret weapon. Keep sharpening those skills and keep quacking forward.